All right, good morning and happy Monday. I'm planning on doing LeetCode contest 302 from yesterday. All right, so here we go. Time to shine. Okay, open these guys up. Okay, so the number of pairs and the number of leftovers. Okay, so use a map for this. It'll be a default dictionary for the counts of X in the input array A. Actually, yeah, okay. For X in A, M sub X plus equals 1. And then pairs will be the counts that are even, right? All right, so for, let's see, we want count in m dot values. Let's see, pairs, and then leftover 0, 0. Pairs plus equals count evenly divisible by 2. Just call this P and L. How about oops, pairs and leftovers? Pairs, leftovers, pairs, leftovers plus equals count modulus 2, right? Whatever can't be paired out. I think so. Pairs and leftovers. Okay, something like that. 3 and 1. 1, 1, 0. 1, 0, 0, 1. Oh, that's good. Okay. Yay. Let's just post this here real quick. Few solutions. 3. Oops. Nice little warm up. Let's see, let's do this in Kotlin. JavaScript. Music. Okay, we'll do it in Rust and C++. Okay, so let's do this. Oops, there we go. Vector integers, and we use a map as our counter. For each value X, the input array A, X is incremented by 1. And then let's do this. Pairs and leftovers. There's leftovers at the end here. And for O count map, P plus equals count divided by 2. L plus equals count modulus 2. Looks good. Cool. All right, JavaScript. A pairs, leftovers. Trying our pairs, leftovers at the end. For each X and A. M will be our map for our counter. M dot set X 1 plus M dot get X 0 if it doesn't exist. For that count of map P plus equals map dot floor of count divided by 2. L plus equals count modulus 2. Oh, excuse me. Okay. Guys, good. Okay, Kotlin. M is mutable map. Integer to integer. Association with X and A. M set X plus equals M set X. M plus M set X. L is not greater than 0. Okay, and then count M P equals 0. P now about P L 0 0. P is equals count by 2. This goes count modulus 2. And we'll return iterate of P L. So pairs and leftovers. Whoa. Insert X. Oh. Oops. Okay, that was good. Okay. And let's do rest last and move on. Choose. Okay. Let mute P, mute L, 0 0 destructured. M equals M equals hash map new. Use the functions hash map turn vector of pairs and leftovers for A. M the optional location of M dot entry sub X dot or insert 0 equals 1 for M dot. So how do you iterate through them? Except for counted M dot values. Is that right? I don't know. Hold on. Let me see. Rest hash map. Into values is fine. Oops. Hold on. To what? Values. Later. Okay, something like that. Fix the compilation errors if there's any. Iter, I don't know if I have to iterate through these values or not. Let's see. Okay, it's cool. Yay. Okay. So let's move on. It doesn't have to be perfect. It's good enough. A little description here. Okay, so use our map and as a counter each value x of the input array A and return the count of pairs P and the leftovers L as the accumulated count of I guess we're trying to accumulate count, right? Good enough. We're using under map M as a counter of each value x of the input array A, and then return the cumulative pairs P and leftovers L, right? Sounds good. Let's move on. And that took 12 minutes, so 1 hour, 18 minutes left. Q1 took 12 minutes. 1 hour, 18 minutes remaining. Contest. Into the. Okay. All right, let's go. We want the two biggest digits. 0, 2. Both numbers have the sum of digits equal to 9. One and four. There are no two numbers that satisfy the conditions. Over all the possible ones. To fifth. Okay, so we want to have buckets of 0 to 9. I guess it can be 0, but 1 to 9 inclusive. Should be just a map. The keys 1 is at 9 and value the the top two max. We could just use a vector, right? Or actually, it could be a Q or something like that too, right? We want to sort each one at the end. That is fine, right? A sorted vector is okay. Sorted vector or max heap. Okay, let's do this. It's 5:33 a.m. Let's see, 5:33 a.m. It's jam. Rotation and 3. Okay. Dictionary of list for x in a. That will be our function which reduces x. Let's see. That's not x. 0, otherwise return x modulus 10 plus f of x divided by 10. Okay, so our bucket f of x terms of f of x and x for each for candidates in each bucket m dot values. Length of the candidates is less than 2. And we continue. Best is 0, and then turn best if best. That's 1. Okay, and then we'll do A and B equals. See, sort candidates, right? Candidates dot sort. A and B will be the last 2. And so -1 and candidates 2, last 2. S plus equals A plus B. Okay, something like that. 104. Uh-oh. Bucket of values. Okay, let's see. What do we got? 9, 7, okay, 13. What? And it's A and B. We'll print these out. How's this possible? Maybe add these and then add these, right? Or... Oh, it's just the max. Okay, I see. It's not all of them. Okay. Okay, so candidate is A plus B. I see. Okay, so best is the maximum of itself and that candidate. Okay. Misread the problem statement slightly. That looks good. Okay, the -1 for the other one. And that's good enough. Cool. All right, let's get rid of this. Should be good. All right. 533, 537. 4 minutes for the implementation of Python. Results. See, yay. Solutions. 3. Okay. JavaScript. Rest. Pause. Okay, let's go. Turn the best. Let's see, so buckets. A. On F. The recursive function which reduces each value x to the power A. Capture yourself in your own lambda. X 0, otherwise return x divided by a modulus 10 plus x divided by 10. Oops, I said that's fine. Oops, let's see. Okay, and then let's do so f of x. Oops, push back x. Each candidate in the map if n is that size, it's less than 2, continue. Turn best if exists, otherwise native 1, if it does not. Sort the candidates. Just sort of reverse order, and then B equals canons 0. B equals canons 1. Candidate equals A plus B. Best equals maximum itself in the candidate. Okay. Looks good. Okay. JavaScript. Okay, let's do F equals X. X 0, otherwise X modulus 10 plus F sub that's a floor X divided by 10. Okay, so for X of A, let's set the array and bucket which X. Okay. Cans run map if candidate length is less than 2, we won't even consider it as a candidate, but it can sort, and we'll sort them in decreasing order. A's cans 0, B's cans 1. Candidate equals A plus B, and the best equals maximum itself in that candidate. That's good. Okay. Kotlin. Best 0, return if best exceeds 0. Best otherwise -1. M is our immutable map of integers to a mutable list of integers. Okay. Let's see, I should do find f so x int if see if x is equal to 0, otherwise x is 10 plus best of x above 10 there, and then say bucket equals f sub x. Map doesn't contain the bucket. I'll say m sub bucket equals mutable stuff integers. Sub bucket dot add x or candidates in our map if candidates size less than 2 will continue. Otherwise, candidates sort. Then a goes. Let's do this. Candidates sort with comparator. Sort that in descending order. Can sub 0, can sub 1. Candidate is A equals B. Best equals the maximum itself in the candidate. Whoa. Mutable. Mutable. Looks good. Okay, cool. And then rest. Save the best for last. All right. Mute best equals 0. If best, return best. Otherwise, return -1. Best exceeds 0. Let's see, hash new functions, hash map. Okay, and then let's see, so FN. X is equal to 0. Return 0. Otherwise, return x modulus 10 plus f sub x over 10. Jackson A. It is f sub x. If map contains it And that insert bucket. Vector. Something like that. Get the bucket and push it there. Candidates and the maps into values. If candidates length is less than 2, continue. Otherwise, candidate sort. Length. A equals cans n minus 1. And so n minus 2. Candidate equals A plus B. X equals maximum of the candidate. Person X. Okay. I think I'm gonna have to fix the compilation here. Yeah, for sure. Okay, max use SD max, what? Oh. Expect, oops. This guy. Bucket, need to consider borrowing it. That's right. Is borrowed ephemerally. Okay. Whoa. Doesn't live long enough. Oh, okay, hold on. Contains, let's do this. Stick it in there. Well, cannot borrow mutable. Cannot borrow is mutable. Cannot borrow cans is mutable. I wonder if we can put a type annotation here. $52 immutable vector. I don't know if this works or not. No, it doesn't like that. Okay. Our hash map. Let's do this. Cans. Cans. To Doesn't like this though, right? Now the bucket. Okay, try to borrow the bucket. Pretty sure it complained about it. Right? Cannot borrow data in a reference is mutable. Does that work? No. What's he complaining about? What the heck? Cannot borrow data in a reference is mutable. Map is mutable. If you do this, dot entry get.com insert vector. No, I don't think that works. Yeah, let's just do this later. Whatever. To the I wonder if we just fix it like this. Expected that. It's flooded everywhere. Still is expecting a reference. Okay. Cannot borrow data in mutable. What the heck? Hmm. Mutable reference? Opera is mutable. Really doesn't like this thing. Cannot borrow data in a reference is mutable. Uh, this doesn't look right. This just doesn't feel right. Ugh. The heck? Hold on. It's not helpful. Cannot borrow. Cannot borrow is mutable. Oh, all right, let's do this then. Maybe I can. What? Whatever. I'll just come back to it. It doesn't have to be perfect. Use a map as buckets. One to 9 inclusive stores each candidate. I guess list of candidates. X of the array. And sort each bucket of candidates to find the best. Place at the maximum. Looks good. Too fancy. Let's move on. Doesn't have to be perfect. Okay, and we have 47 minutes left of the contest. 47 minutes remaining in the contest. Great queries. Okay. Okay, so trim each of them and then return the maximum. Okay, sounds good. I'll just do form. This is the game plan, right? Game plan is to perform the simulation for query, right? Answer. Right. Answer. Okay, so for what was the first part? Kth, determine the index of kths. Oh, the fourth smallest. Okay. The first smallest. Okay, so it's K and then trim, right? answer to return instead of append. Zero base index. Sorted. We want the rightmost 2 digits, then we divide it by 100. So it's 10 to the power of the rightmost digits. X modulus 10 to the power of trim. All right, it's 1, it's the first one, 2, it's the first 2. Okay, something like that. X is not defined. Oops, for X and A. Oh, sorted this guy, so that arguments converted during string formatting. What do you mean string formatting? What the? What is going on here? Print this guy for a query. What sorted? It's a list of strings. Oh, I see. Okay, that's why. Okay, that makes it a little bit easier actually. So X. I want the. Yeah, whatever. We can just do int X, right? String, I guess. A string. That is not right. Oh, I see. Okay. First, second, third smallest index. Okay. So we need to find the index of that value. Okay, yeah, so target is this guy. So append. This is a sorted A. Target is S of K minus 1 for 0 base indexing. Index of T. Uh-oh. I'll just index. That is not right. What happened here? ST query. First smallest, second smallest. Before it's sorted, I guess. Okay. B equals this guy. Or actually, what do you want? The met? No. Oh yeah, we do want to sort this. Sorted B. Target is that, and then index of the target. That's what I want to push onto there, right? So this guy here. That looks good. 2210. All right, 2210, and then 30 for the next one. Come on, come on, come on. Uh-oh, it's not finding 3. Okay, so the first one is correct, but the second one is wrong. Second smallest of the last digit. 0, 1, 2, 3. The one at index 0 is considered smaller than the one at index 3. That's fine, right? K is 2, so it should be 1. So what's going on here? Target is S target, and the index of the target. I want the second instance of it though, not the first. So it's the same value. I want the second instance of the same value. Okay, so we'd want to return m sub t sub k minus 1. That's what we'd want to return, right? Not the index. Two, 2, 1, 0, and 3, 0. Uh-oh. This index out of range. Uh-oh. What am I putting here? First digit, 4, 4, 6, 7. Target is 4. And we want the second 4, which is 3. So what happens for 2, 2 then? Oh, I see. Okay, so there needs to be some logic for what's the second biggest? And what is the index of that? Yeah, so there's a corner case here that I'm not handling very elegantly. Second biggest, and then the index of that second biggest. Index of the second biggest. Grab some more coffee real quick. Maybe I should push up the index. I may push the index on there, make it more convenient for myself, right? When I'm processing it. What if we do? Okay, this is our value we'll sort by, and this is the associated index with that value. I as in enumerate. Okay, so then we don't need this. Sorted that. There's our target, and then so the target's of 1 would be the index 3 and 0. Okay, so that looks good. 1, 3 and 0. 2, 2, 1, 0. Okay, that looks good. Yay. So I don't know if I want to clean this up more or not. I mean, we can, right? We can just totally shoot this up, but it'd make it hard to read. All right, so we do and instead append sorted B, so P minus one, so one. Right, I mean, this works, I think. It's just hard to read. There's a cool. I think so. Yeah, so then we can do this, right? So turn. Just trim it up here. Something like that. Oops. Okay, and then what we can do here is just trim this guy. Trim this guy. This stuff, this guy was and solve a queries. Something like that. Oops, hold on. And sweet little one-liner. All right, that's cool. Okay, yeah, let's just push this. That's cool. Solutions. Iteratively refactored to one liner. And on three. Perform the simulation. Yeah, good enough, right? Yeah, that's cool. Okay, it doesn't have to be perfect, just good enough, whatever. 25 minutes left for Q4. Q4. Unicorn to tackle. She keeps escaping me. All right, let's get to it. All right, 25 minutes left in the contest. That's enough time, right? All right, 25 minutes is cool. All right, let's do this. Minimum deletions to make array divisible. Let's define the smallest element is 2, which does not divide all the elements in num divide. We need 2 deletions to delete the number of elements. Okay, delete those 2 2s. Smallest element divide all those. There's no way to delete elements from nums to allow this. 4, 3, and 6 don't divide all those values. Smallest number that divides them all. So we need the greatest common denominator. Does that sound right? I guess 1 would always be a good solution. I think we do need the GCD, right? And then defines them all. Doesn't have to be the greatest. Is it the least common multiple? Neither offhand, just thinking like GCD. And GCD or LCM. Something like that to reprocess, input to restrict candidates to avoid TLE. Since it is 25, it's 100,000. Looking at linear solution. Save it. It's gonna be A. It's gonna be B. Balance equals 0. Return dells. If it's possible. Turn A, if not B, else GCD A modulus B A equals, let's see, B equals. We want B to be the small one, A to be the big one, right? Oh, wait, hold on. This isn't gonna work. So we need something like maybe the sieve of Eratosthenes. Sieve of Eratosthenes. Sieve of Eratosthenes. This guy. So we want, it's not just the GCD of 2 values, it's like the whole chunk. I can cross them out basically. This is our pre-processing step. Use the search space. Candidates. So. Well, this is finding prime numbers. Okay, I don't. That's not what I want, is it? You might want a version of this thing. Translations to make array divisible. Okay, how about this? Once again, I don't know. Let's experiment, right? What does root solution look like? Right, so go brute force, then optimize. How much time do I have left? I got 17 minutes. Contest. 17 minutes is enough. Come on. I think I can. Okay, let's do this. M is our counter. Oops. Integers. X and A. M is X. X 1. Relations each X. A dot sort. And then for X and sorted A. For Y and B, if all Y modulus X is evenly divisible turn it back, I'll break. Otherwise, del is plus equals M specs, right? Okay, that's what a brute force would look like, I think. Should be 2, it's 4, that's not cool. So X. Okay, X. RNG. X is no good. 2 is no good. 2 is no good. Oh, okay. Set of A. Sorted set of A, so don't count it twice. Okay. And then -1 for that other case. Del's is less than the length of A, otherwise -1. I think -1 for that case. 2 is no good, 3 is no good, 4 is no good. Yep, okay, so that's brute force. This is expected to TLE, right? expected to TLE. Okay, so that's expected. Okay, so now the question is, oops, to optimize. That's for AC, right? Is to try and them all. I need to just pre-process B for those candidates that work, right? Maybe the smallest value in B is what we're looking for. Right, find the smallest value and then look for X which divides B. And then Y. Okay, let's try that. Target is not B if any Y modulus T on B turn -1, right? So it's not evenly divisible by that. We can bail early. If modulus of X included lies for any X that does evenly divisible by T. So not cool, right? I think. It's 3. Wait a minute. This must be 2. Three is what we're looking for, right? Print T, we're looking for 3. Answer is 3. What? What's going on? 2 is no good, but 3 is okay, right? What? Was that no good? Target is 3. Sorted A. Sorted set of A. 3 modulus 2, but 3 modulus 3 is, oh. Oh, I see, okay. If not this, then we'll break early. Yeah. Otherwise, okay, that looks good, something like that. Okay, 2 and the -1. Okay, and then this one cool, gigantic thing. Ooh, yeah. Maybe it's okay. It's still, it's linear, right? It's not quadratic at least. Let's see what happens. Big money, no whammies. Ooh. 6, but I'm saying -1. Uh-oh. Okay, so this return really doesn't work. But I still need to find the target, right? Should be 6. 0 is not right. And the sorted set of A, this guy. Delete 1, 2, 3, 4, 5, 6. So 8. Yeah. How is this 6? So there's 7 of these, right? What? 5 divided by 35 is cool. 175 divided by 35. That's cool, but 105 divided by 8 is not cool, right? What the heck? How is this possible that the number of deletions is the smallest element and none divides all elements and none divides? 2. 2's no good, 3's no good, 4's no good, 5's no good. 1, 2, 3, 4, 5, 6, 7. How is it 6 though? What? I thought it'd be 7. 1, 2, 3, 4, 5, 6. The heck? So is this expected to be 6 instead of 7? 35 evenly divides all values. 8. X is no good, right? These are the ones I delete. Wait a sec. Print. Sorted set A. I'm not seeing anything printed out here. For action sorted set, T is the minimum. Ah, scheiße. Okay, 4 minutes left. Yeah, so this one, to may revisit when I'm fresh. Gotta take a break. A little worn out. I get 70. X is okay. Should be 35, which is okay. Okay, is 2 what? 2 most certainly does not even, oh wait, 2 does evenly divide 70. Oh shit, okay. Oops. Okay, so this is, yeah, this is totally incorrect algorithm then, even for brute force, because 2 divides 70, but it doesn't divide these other ones. Let's see this least common, yeah, least common multiple is what I was looking at earlier, right? Or think about least common multiple between all these values, right? I want the, consider them all though. Yeah, so 2 minutes, okay. Consider them all. Yeah, this is what I was thinking, like prime factorization, something like this. Right, this is what we want. Prime factorization, right? Yeah, something like, yeah. Deduce candidates via inversion of C of error plus the names, right? This guy. Or prime factorization. Prime factorization of all Y and B in union that to reduce the search space for X and A. X and A based on the C of their responsibilities for prime factorization, all Y and B, something like that, right? Yeah. Okay. Yeah. To do absolve something like that. All right, we got 57 seconds left. I'm not going to solve this in 57 seconds, I don't believe. So, yeah. Thanks for watching. Cheers. Yeah, hopefully it's helpful. Just jamming on this, having a good time, waking up the brain. And I have lots to do for actual work here. I'm totally stoked to start getting on. So, yeah, we'll catch you next time. Bye.